Hello and welcome to our programming video. I'm Nathan,
And I'm Joseph.
and we're going to be going over the basics of programming in FTC. In FTC, there are two main ways of programming the robot, and those are using blocks and using Java. There are a few other options you can use, such as C++, but we don't really advise using that because there's not nearly as many people out there using it for FTC. And if you had issues or difficulties, it would be a lot harder to find help online. With blocks and Java, there are pros and cons to using each, and we're going to go over several of those. One of the main pros of using blocks is that you can't have syntax errors. Or if you can't have syntax errors, it's very difficult to do so. For the most part, you take the blocks you want, you put them in the order you want, and it will compile correctly. Whether it runs correctly, well, that's your responsibility. But it should be able to compile without any difficulties. Another pro is that all of the libraries that you're allowed to use, all of the methods you're physically able to do, all of that is already included. You've got all of that in the window to the side, and if you ever need to look something up, you can simply scroll through all of the options and find the method you need.
So there are also cons with using blocks, one of which is that you are actually limited by that predefined library. So it's kind of a pro in that you have access to everything that blocks can do already, but if there's something you need that blocks can't do, you won't be able to get it because you can't import external libraries. It's also very hard to write long mathematical statements. They're complicated, they are confusing, both to write and to read, and it's just a lot simpler to do in a text-based language. You also can't use any object-oriented mechanics, and object-oriented mechanics like objects and inherency and all those fun things really save you a lot of time as a programmer. You only have to write stuff once, you don't have to copy and paste, you can just call things from different locations, and that makes it a lot easier to write your code, and this just simply isn't present in blocks.
With Java, a lot of our pros are the inverses of our cons for blocks. For example, if you're using Java, you're able to use more advanced concepts like classes or methods or arrays, things that simply don't exist in block because they would have been far too complicated to have made. You also can import additional libraries. If you're wanting to use some mathematical method or some other method that some other programmer has written, you can simply call those into your code and reference it as if it was a method you had written for yourself. You simply can't do that in blocks. But the main reason we think you should look into doing Java is that Java is an actual language that people use in the real world. If you know how to use Java, you could take those exact skills and apply them in a future career. You can walk into an interview later down the road and directly discuss the programming experience you had and how it's relevant. If you were to walk into that same interview and say, hey, look, I have experience using blocks, they're probably going to laugh you out of the interview. Blocks will allow you to learn the basic concepts, the basic logic, but you won't be able to use the exact technical skills in real-world applications.
The cons for Java are mainly just a steeper learning curve, because Java does have a steeper learning curve than blocks, but it's not by much. Mainly for Java, it's the syntax that is different from learning blocks, because really the steepest part of the learning curve for learning any programming language is learning how to do logic and learning how to program logic. And so if you're going to go, if you're going to take the effort to learn how to program logic, you might as well just go that extra step and learn the slightly more complicated syntax of Java in exchange for getting real-world technical skills.
Here we have an apples-to-apples comparison between a code segment in blocks and a code segment in Java. As you can see, the same elements are there in both of them, but in Java, you actually have to write out the brackets and the semicolons and all those different things. You can see how when you're writing code in Java, there's a lot more opportunity to make a mistake, to not put one of the brackets, or to accidentally delete something and cause an error to happen, something that's not possible in blocks. But if you're wanting to use programming in the real world, these are skills you need to learn, these are habits you need to get into, and doing it now is just as good a time as any.
So basically the message that we're trying to get across here is don't be scared of using Java. I know it looks scary, but it's really not too hard to learn. And there's this stigma around programming that it's really hard and complicated and that only really smart people can do it. But that's just simply not the case. It's misrepresented. It's really not that difficult to learn, and it will definitely be worth it in the long run. Once you've decided which programming language you're going to use, you'll need to make a decision about what software you want to use to program your robot. The two that we would recommend are either OnBot or Android Studios. And this is, again, just like with the languages, that they're the two most commonly used with FTC, so they're going to have the most documentation on them. So we're going to start with OnBot, and some pros of OnBot are that you don't need to download anything. It's all on the FTC app on the Android phone. It's basically just plug and play. There's nothing that needs to be downloaded or set up. It also has wireless connection to your computer that you're using, and fast code download.
Now, of course, there are a few cons that go with it. For starters, connecting over Wi-Fi means you have the risk of connection issues. It is incredibly infuriating, but yes, you will spend a very large amount of your FTC time waiting for the phone to connect with the computer, or the control hub to connect with the computer. It's infuriating, but it is simply how OnBot will work. Also, there is another issue that you can have. It won't regularly back up your code. It will only keep the most up-to-date recent version of your files. If you make any changes and save them, and then decide later you want to go back and see something you've done earlier, there won't be any record of it. You can back these up by hand, of course. You can physically take the words and files and put them in another location that you can reference. And we strongly advise that in case you ever need to go back and see something. But it will not automatically do that for you. Tied to that is it is difficult to work from home. All of the files are saved on the robot, either phone or RevHub. And you won't be able to work on those files remotely unless you've made a copy of these files to edit. So you can make it work. There are workarounds you can look into, but it won't do that automatically for you.
Android Studios, which is what we use this year, has some pros that we really like as programmers. The first is that files aren't saved on the phone/control hub, so it's much easier to work from home. So like what Nathan was talking about with OnBot, this is different. The files are on your computer, so it doesn't matter where you are, you can be writing code for your robot. Another pro is that it has fancy bells and whistles like autofill, syntax error highlighting, and debugging. So it makes your code writing experience a lot more efficient. If there's something wrong, it will flag it and tell you what's wrong, and oftentimes it will also give you solutions on how to fix it. And 9 times out of 10, what it suggests is correct. So it just makes programming a whole lot easier and more efficient. It also has built-in GitHub functionality, and we've been using using GitHub this year, and it has been extremely helpful because it's kind of like a failsafe. It holds backups of your code, and it also allows multiple people or just even multiple devices to work with the most up-to-date code, regardless of who's edited it.
Now, of course, Android Studios is not perfect. It has cons of its own. For starters, it is a massive program. It takes up a lot of memory to download this. Now, odds are you'll be using your school computer for this, or maybe a personal computer. The school computer has plenty of room to store Android Studios. You're not going to break the bank with this program. But it is a really big file, and it can be kind of frustrating to have to deal with all of those folders. You also have to use the wired download, which means first off you have to physically connect it, which is not as convenient as being able to just do it wirelessly. You're going to have to get down and find the port on the robot and plug it into your computer. It also is frustratingly slower than the wireless download, and that's just going to take more of your time up when you're trying to do active testing. So once you've decided on the type of programming language you're going to use and the software you're going to use, the next step is to actually start writing your code. And often this can be the most daunting task because it's hard to know where to start. There's only a long list of things you have to get done, and it's hard to decide where is it I should begin. The first thing that we would advise you start with is simply the drivetrain. If you want to be able to compete, you have to be able to move. If you're not able to move, you're just dead weight, and you're not going to do any alliance partner any good. So make sure you're able to physically move. Whatever drivetrain you have, it might be Mechnum wheels, it might be a tank drive. Whatever it is, make sure you're able to physically move around on the field. Once you have that done, just make a list of all of the mechanisms your robot's going to have. It might be a lift apparatus, it might be a shooter, it might be some sort of arm. Whatever it is, make sure that you've got it programmed. We'd advise putting this in order of importance and then just start at the top and going down that order. Once you have all that done, you can start simply taking the code and copying and pasting it into your autos. If you have a method to close an arm, just take all of those code lines and put it in the order you want, tell it how long you want it to run, and then you can just play it all back, and hopefully it'll work correctly. After that comes the funnest part of programming, the fine-tuning. The adjustments, the improvements, this thing that will consume most of your time in FTC. This will go on for the rest of the season. It will go to the very last minute of the very last match of the very last competition. There will always be slight changes, slight tweaks, slight improvements that need to be made to make sure your code runs as effectively as possible. If you find yourself with some free time outside of these, there's lots of other unnecessary cool things that you can just start messing around with. That could be LEDs on the robot that light up to make pretty patterns or indicate things to the drivers. It might be sounds that the robot makes when it completes certain tasks. Whether maybe when it parks at a certain position, it will make a funny noise that will make the judges smile or something. There's lots of other cool things that you can look into doing with that isn't strictly necessary for FTC, but it can be an extra fun thing programming can get involved in.
So regardless of which step in the previous slide you're on, you will need to be able to program and be, familiar with the hardware that you're programming. So we've divided this hardware up into 3 categories. The first is actuators, and actuators are basically anything on your robot that moves. So this primarily means motors and servos. The second category is sensors, and you really need to be acquainted with these because you will probably spend the most time programming this category of hardware. And sensors include gyro sensors, color sensors, range sensors, touch sensors, and motor encoders. And it's a really good idea to utilize these sensors in autonomous programs. Thirdly, we have controls, and these include the Rev Control Hub / Robot Controller Phone, depending on which route you decide to go, whether you use the Rev Control Hub or the separate Android phone for your robot controller. Also, we have the Rev Expansion Hub, which is basically the Rev Control Hub, except you don't download code onto it, but it also helps run your peripheral hardware. We also have the Driver Station Phone, and this is what you will plug your remote controls into to drive and use the robot during teleop. And what you plug into this phone are specifically Logitech F310 gamepads. So over here we have a picture of a control hub, and then this is a Go Build a motor, and that's a Rev motor, just to kind of give you a taste of what these things look like.
To help you get started with your programming, we've made a list of some concepts we think would be a good idea for you to research and see if you can apply it to your robot. The first is omnidirectional driving. I know, big scary sounding word, it's really not that complicated. Basically, you tell the robot what direction you want it to move at, and it will move in that direction. So if I wanted the robot to move at 30 degrees, you would have all the math happen behind the scenes, tell each motor how fast to spin, and then it would move you at a 30-degree angle at whatever speed you set it to.
The second concept is augmented driving, and this is often referred to as field-oriented driving because you can drive in the direction of your controller joystick regardless of the robot's orientation. So this concept really kind of piggybacks off of omnidirectional driving.
Another one is logarithmic controls. It sounds, again, kind of complicated, but if you start getting into the math, it's really not. Basically what it does is it allows the driver to have more control over the sensitivity of the joysticks.
The fourth concept is proportional controllers, and these sound more complicated than they are. Basically, if there's a target value that you want to approach for a hardware device, like a motor, like you want a motor to rotate to 10,000 encoder ticks or whatever, a proportional controller will change the rotational speed of the motor as you approach that value, and it'll slow it down so that you hit right on 10,000 encoder ticks instead of overshooting or undershooting.
Speaking of encoders, we strongly advise you look into driving with encoders. Most of the time, when you're just writing your first teleop or auto, you'll simply say drive at this speed for 3 seconds. And that might sound good, that might sound simple, but you're now completely at the whim of things like battery level and motors overshooting. Being able to use encoders will allow you to be significantly more accurate with your driving. You won't be at the whim of your battery being too high or your battery being too low. It's not perfect. It will still overshoot every now and again, but it will be significantly more accurate.
We've also chosen to include some more advanced concepts, and you do not have to do these by any means. We just thought to include them in case you were interested. The first one of these are PID controllers, and this is basically just an extension of proportional controllers. So not only will it proportionally adapt to whatever value you are at in relation to a target value, it'll also take into account the accumulated error, or adding up all of the little error values over time between how far you are away from your target value. It'll also take into account the rate of change of your value in relation to your target value.
The last concept we thought we should jot down is odometry. This is basically using a set of encoders that aren't connected to any motors. That way it can more accurately measure the robot's position. You don't have to worry about the wheels spinning and it counting movements that it's not actually making. It will be a lot more accurate. It will take some more math behind the scenes and it's some more hardware outside the robot, but if you can get it set up, it will improve your accuracy when measuring distances. When you're first starting to program, there's a lot of research you need to do. There's a lot of documents you need to read, there's a lot of videos you need to watch, and that can be a very time-consuming process, mainly because you really don't know what you don't know. In an effort to try to help with that, we've put together a programming resource file. This is just a Google Doc that we will be hopefully putting on the Edpuzzle. If it is not there, go talk to Bailey and Maddie and ask them whether you can find that document. This document contains tutorials for both block and Java FTC programming. It includes documentation that FIRST has provided specifically for FTC programming. We included several different tutorials for basic Java programming. Don't watch all of them. That's way more than you need to do. Most of them cover the same content. It's just different people presenting it. So we'd advise listen to a couple of them and find someone who you really like his teaching style and then just watch through their series. We also included a large variety of math playlists, including math classes from algebra all the way up to like calculus 3. No, you do not need to know calculus to do programming. That is not a requirement. But if any of those concepts were to come up, or if you had any questions, those are things you could look up. We would advise, though, you look into your algebra and trigonometry. Make sure you've reviewed that and it's up to date, because those are things that you will be using very often inside of programming. At the very end, we have an other tab that links a physics playlist and a statistics playlist, because those are also concepts that you might find yourself needing to use when you're programming the robot. And remember,
fear the null pointer exception.